Hey guys, Mr. L again. Okay, so we are going to be looking now at lesson 3 in module 1, topic A. So this is going to be looking at identifying proportional and non-proportional relationships in tables. This is something we've seen a whole lot of, so should be comfortable with this. We're going to move kind of quick here. You have been hired by your neighbors to babysit their children on Friday night. Good information, doesn't help me really with the problem. All right, you are paid $8 per hour. That does help me. Complete the table relating your pay to the number of hours you worked. Well, all I have to do here is for every 1 hour worked, right? My unit rate is 8/1. Every 1 hour worked, I'm making $8. So for one, 8. For two, I'm sorry, it's not 8. Why did I write 8 there? For two, it is going to be 16, right? Because I'm just doing times 8 times 8 times 8 all the way down here. So 24, and I'm going to skip down to the bottom. We'll do 6.5 times 8, which is going to be 52. All right, which is 6.5 times 8. So 8 times 5 is 40. Carry the 4. 8 times 6 is 48, plus 4 is 52. Move that in once. So that's 52. Okay. And I'm going to have you guys fill in the rest of these on your own. So that's not a problem. Now, the question here is, based on the table above, is the pay proportional to the hours worked? Is it proportional to the hours worked? Well, yes, because it's a constant rate, right? A constant rate. Because wherever I have 1 hour, I'm gaining $8. Moving on to the exercises here. For exercises 1 to 3, determine if y is proportional to x. Justify your answer. When we mean justify, right, we're thinking prove. Okay. The table below represents the relationship of the amount of snowfall in inches in 5 counties to the amount of time in hours of a recent winter storm. So if we want to know if this is proportional, again, we keep going back to that proportional there. If we want to know if this is proportional, then that means that these all have to be the same value, right? So if 1 snowed for 2 hours, well, how do I get from 2 to 10? Well, I'm going to divide in this case, right? Because I want to go the inverse, I'll go backward. 10 divided by 2 equals 5. Okay, let's do the next one. 12 divided by 6. Hold on. Well, that equals 2. Hold on, this doesn't look right. Let's do the next one. 16 divided by 8. Well, that equals 2. What about 5 divided by 2? Well, that is 2.5. So all of these are proportional. However, this one here is not, because that is a unit rate of 5. These others have a unit rate of 2. Okay, so these are not proportional. They are not proportional because of this, right? Because we have one data set that doesn't match. All right, let's go on to the next one here. The table below shows the relationship between cost of renting a movie in dollars to the number of days the movie is rented. And we would hope that that would be proportional, but maybe it is not. Let's take a look here. So for every 6 days, we get $2. So let me see here. Again, we're going to take that 6, we're going to divide it by 2. 3. Okay. Let's do 9 divided by 3. 3. So far, they all appear, and you go through and do the rest of these, then this one is, in fact, yes, it is proportional because they all have a unit rate of 3. Spelled they wrong. Wow. The same unit rate. Okay. The table below shows the relationship between the amount of candy bought in pounds and the total amount of candy in dollars. All right, so let's look at this. I'm going to go from my y to my x. Okay, I could go either way, but I'm going to go from my y to my x, and I have to have that same going again, back and through. So we have 10 divided by 5. We have 8 divided by 4. We have 12 divided by 6, 16 divided by 8. And those that are reading ahead or moving ahead of me can see that these are all going to end up with a unit rate of 2. Yes, they are. Boom, because they have what? They have the same unit rate. Okay. This we should be comfortable just putting in there. Make sure we're writing that full sentence out. Okay. Number 4. Randy is planning to drive from New Jersey to Florida. Every time Randy stops for gas, he records the distance he traveled in miles and the total number of gallons used. Assume that the number of miles driven is proportional, which means that we're going to have the same rate, to the number of gallons consumed in order to complete the table, which means that there's no funky math. Whatever we're doing in data set A, we're going to do in B, we're going to do in C, and D, and E, and F. And I see this written horizontally. It doesn't matter horizontal or vertical. It's the same process. Okay. So I need to figure out first what my rate is, which means I'm going to take my miles driven, 54, and I'm going to divide that by 2. 54 divided by 2, if you've done it on a calculator, you've done it in your head, I'm going to do it out like this. So it's 54 in my box, 2 outside, 2, that's 4, 1, bring that down, 4. And I'm doing this, this way. You can certainly do it with that, either way, however you want to do it. Or if you just know it off the top of your head, the way I do this is I see 54 is kind of like 50 cents. And I know that 2 quarters are going to get me to 50. So it's 25, 2 quarters, 25. And then I need 2 more. So that's going to go in there. So then I just need to take each of these and multiply it by 27. So it's 27 times 4. Now here, because I'm going the opposite way, I have to divide it. 180, 89 divided by 4. Here, 27 times 10. And here, 27 times 12. Okay. So I'll have you guys solve that. I think that's something you can do on your own. Whatever strategy you use, feel free to go ahead and fill those in. And then when we get to the lesson summary here, a type of quantity is proportional to a second if there is a constant number such that the product of each measure of the first type and the constant is equal to the corresponding measure of the second type. Basically, what this is saying is that we know that if it's proportional, if you can apply it to every single data set, every single relationship, every single set of numbers that you have here. If it doesn't match even one of them, then you do not have a constant proportional rate. Okay, so the problem set's going to be 1, 2, 3, 4, and 5 in each table. I'm sorry, in 6. In each table, determine if y is proportional to x, explain why or why not. So here, I just need to figure out what do I have to do to my x to get to my y. What do I have to do to my x to get to my y? If it is the same through all of these, and it's with multiplication or division, if it's the same with all of these, then it's going to be a constant rate. This one is a little, number 3 is a little more challenging, but you should be able to use your dividing with decimals to get that solved. Okay. Number 4, Kayla made observations about the selling price of a new brand of coffee that sold in 3 different sized bags. She recorded those observations in the following table. Is the price proportional to the amount of coffee? Where and why not? Well, I have to figure out how I got from here to here. So I'm going to take my 210 divided by 6, 280 divided by 8, 560 divided by 16, and it should all come to the same number. I'm going to have you guys do 5 and 6 kind of on your own. This data set or this problem set is a little bit longer than what we have done, but get as much done as you can. And if you have any questions, let me know. Thank you.